The focus of this presentation is to let you understand the theorem. The angle subtended by a diameter at the circumference of a circle is a right angle. This is a special case of angle at center is equals to twice angle at circumference. This is the abbreviation. Understanding the theorem. Let us write it in the if-then form so that you can identify the hypothesis and the conclusion. If a diameter subtends an angle at the circumference of a circle, then the angle is a right angle. In a diagram, we have the circle subtending angle C through the diameter AB. Then that angle is an angle of 90 degrees. So the given represents the hypothesis. The required to prove is the conclusion. Now we draw a situation where the red part is part of the circle that is partitioned into two portions by the chord A, B. So if we label angle at C, theta, angle at the center, beta, then we are saying what we want to prove is the angle is a right angle. That means theta is equal to 90 degrees. So the thinking pattern is start with an end in mind. First, think in terms of the end. That is theta is equals to 90 degrees. That's what we want to arrive at. Right? So the transitive property, a relationship between three elements, is often handy or useful in this type of a proof. Think in terms of the start, the given. What theorems or properties can you deduce from the given? Right? A chord, and in this case, it is a diameter subtending an angle on the circumference, suggests the angle at center is equal to twice angle at circumference theorem. Right? This will lead to the formulation of an equation that contains beta and alpha. Also, AOB is a straight line. AOB, it is a straight line, and we can formulate an equation in beta. So, AOB is a straight line passing through center O. Therefore, angle subtended by the arc ACB at O is beta, but that beta is equal to 180 because AOB is a straight line. Also, beta is equal to twice theta because this is the angle at the center, which is twice angle at the circumference. Right? So using the transitive property of equality, we have beta equals to this, beta equal to 180. So 180 should be equal to 2 theta. Dividing both sides by 2, you get theta is equal to 90 degrees. Proof is complete. Right, understanding the converse of angle in a semicircle theorem. If a chord subtends an angle of 90 at the circumference of a circle, then that chord is a diameter of the circle. In a diagram, you are given that's your hypothesis. Now remember, converse, you switch the hypothesis and the conclusion. So the conclusion now is the hypothesis. Angle at center is 90 degrees, then you can conclude that the chord subtending it is a diameter. Right. The given represents the hypothesis, the required to prove represent the conclusion. So to prove this theorem, use angle at center twice angle at circumference. It becomes very easy. So key takeaways from this presentation: angles at center and circumference should not face each other. Always start with an end in mind. This leads to the use of the theorem angle at center is equals to twice angle at circumference and angle on a straight line to prove that theta is equals to 90 degrees. The transitive property of equality is useful in this proof. Okay, I thank you very much.